Okay, so we are at a stage right now where we have already got the EKS Anywhere admin machine created through Terraform. We already have built the OS template for our EKS Anywhere nodes and further customized that OS template to include some of the packages additionally that we require and the SSL certificates and everything to be actually placed on the within the OS template. Now, at this point, we will be actually understanding how to prepare the YAML file for the EKS Anywhere cluster deployment. Now, this YAML file is basically used by the cluster API, which actually operates under the covers. And we really don't get to see that interaction at a detailed engineering basis, let's say that. But the point is that EKS Anywhere software, when you issue the command to create cluster, you have to supply a YAML file. And that YAML file is a opinionated and declarative set of resources, both in terms of the machine configurations that are required for the cluster nodes. And those machine configurations and things like that presented in the YAML translate into resource requirements, which are sent over to vSphere. Okay, how does that happen? It's all under the hood of EKS Anywhere, but primarily it uses Cluster API. Now I'll show you how the YAML file looks like in a visual sense. Okay, so you can look at, imagine a file where you have at the top of the file the main cluster config block, and you can look at this file. Let me just zoom in a little for you. You can see at the top of the file, the block is defined as the resource kind cluster and with a certain amount of metadata, and then the specs. In the spec, you can see that there are references called as data center ref, and the kind is vSphere data center config. And there is a name bearing, which has a one-to-one correlation with a sub block in the same YAML file. So you can see that the name here and the name here is the attachment between this particular spec and this configuration block, which is identified by vSphere data center config. And in this particular block, you will have to define your own data center, the network that will be associated with the cluster, the endpoint of your vSphere, and the thumbprint for your SSL certificate for the vSphere endpoint. Likewise, you can see that there are three sub-blocks, one for control plane nodes, one for etcd nodes, and the other for worker nodes. And all of these have a correlation to the main cluster configuration block in this spec. So you can see here, while I determine the control plane configuration for this cluster, I can specify the node count and the API server IP that will be running. So this is a manual insertion of a static IP address that I have to give for the API server that runs on the control plane. But there is a correlation now you can see to the actual machine configuration that will be used for this control plane nodes, which is here. And the type or the kind of resource is called as vSphere machine config. I will have to define the spec for this sub block, which is basically what is the data store that will be used, for the control plane nodes, the disk, the folder in which it will be hosted in the vSphere inventory, and then the spec in terms of the vCPU and the memory, whether it is going to run Ubuntu or Bottle Rocket. In this case, in the blog series, we are operating things on Ubuntu. And the earlier template that we had created, the OS template, so the name of that template, and then the resource pool, the default user with which you can SSH into, and you necessarily don't have to provide your own SSH keys. If you leave it blank, it will just auto-generate the SSH keys, and they are automatically placed inside of the EKS Anywhere administrative machine within a specified folder, so that you can access it later on. So likewise, so this is called as a vSphere machine config, configuration block, let's say that. Likewise, you have it for etcd, and likewise you have it for worker nodes. Note that you cannot mix and match things here. You have to keep things consistent in terms of the, at least the common ones like data store and the, the OS that is used for. So you can't have a Ubuntu for one etcd nodes and then bottle rocket for control plane nodes. All of them will have to be Ubuntu. The template reference should be the same. So primarily they're all same. Only thing you can change is that the size and configuration of each of these blocks can be different actually, right? Now, you look at all these sub blocks feeding into this particular main cluster config block, and that's how a YAML template looks like. Now, I will show this YAML template to you in the actual EKS Anywhere administrative machine of mine. But before we go there, in the blog itself, I have highlighted this particular template. So you can see here in the GitHub also, from where the cloning happens, this is the EKS Anywhere under my user ID. Here is where I keep a list of all the exhibits and artifacts for various things and automation scripts and whatnot. So there is a subdirectory here called as cluster samples. So when you create the EKS Anywhere machine, this particular directory is automatically cloned into that particular machine. And there is a cluster sample.yaml here. Okay, it's the same thing that you saw visually is now presented in the actual YAML sense. So you can see these are the sub blocks, for your the etcd nodes, for your worker nodes, and for your control plane nodes, and the data center configuration, and then the the parent cluster block basically, which references each of those sub blocks. Another thing to note is the sample that I have provided is it was created a while back, so it has Kubernetes version 1.1 listed, and likewise the OS template that I have provided in the sample, the name of it is version 1.21. So in order to prepare a baseline YAML, which can be reused over and over again, the only thing that you will change in that is the workload cluster name and all occurrences of that. So there are some static terms that I've used so that you can do a search and replace quickly to create a nice template. So that and the API server IP address. So only thing you change is the workload cluster name, the management management cluster name, and then the the IP address. So in order to do so, we can use different bash scripts. I have given some of the bash scripts, which we will see in the next set of articles. At this point, let me log into my admin machine, which is the EKS Anywhere admin machine. And I'm logging with an IP address of .50. For you, it could be different. If you have built this machine using the Terraform modules that we have in the first articles, then the default password, unless you have changed, is Ubuntu. So Ubuntu. And when this machine was created, and like I said, the EKS Anywhere Git repository is automatically cloned into it actually. So I will go to cd cluster samples, and you can see that the cluster sample is already presented here. Now, what I've done is, after this was cloned, I have manually edited this to create my baseline template from which I will feed off in terms of creating the clusters and just do some minor tuning. So if I do a quick check on this, you can see that I have changed, for example, my Kubernetes version here is 1.22. I've just changed it in this file. And then likewise for the OS template, I have also inserted my thumbprint and the OS template also references the 1.22 customized OS template. So what I wanted you to understand is how this template is constructed. At a bare minimum, like I said, you will have to change these values to create this, basic baseline template, let's say that. And once you are done with this, in terms of creating the clusters, we will reference the next set of article and videos to see how we have created simple bash scripts around the EKS Anywhere create cluster command. Doing some of the search and replace of these strings that are statically placed intentionally, like this one, for example, will be replaced with the actual cluster name. And then, you will have a nice metadata, which will be your cluster name, a -cp and things like that. We'll see all of that in the upcoming video and articles. Thank you.